Okay, class, can you see the slide? Okay. Can you hear me?
Can, sir.
Can, okay then. Okay, class, so let's start. So today what we're going to do is the last topic of your A2 syllabus. Okay, this topic is about telecommunication. It's about how your signals has been transmitted, how your phone signals are transmitted. When you talk, what happened to the sound signal and how it was aired, and finally how to reach your friend and so on. That's our discussion. Okay, today's lesson we're going to talk about the mode of transmission, how the signals transmitted, through what they transmitted, what type of wire they use. That's today's lesson. Okay. So yeah, these are the communication channels we have so far. All the signals we have, your TV signals, your radio signals. It was transmitted through this one of this mode. First is the wire pass. Second is coaxial cables. Third is a radio waves. Fourth is a microwave. And the most ultimate, which is we can say the super transmission, the best transmission ever by using optic fibers. Okay, so we'll discuss plus and minus of this mode of transmission. Okay, first, this is all the how it should look like. This is your wire pass. On the left corner is your wire pass. You have 1, 2. In this case, you have 1, 2, 3, 4, 4 wire pass. Normally used for what do you call for phone calls in 1980s, maybe early 1980s. They used this wire pass for phone calls. Okay, this for your house. The second one maybe for your neighbor and so on. Yeah, so the wire pass. Now we don't use wire pass for the phone calls anymore. Next is a coaxial cable. Coaxial cable. Yeah, this is how it looks like. More advanced than wire pass and radio link and microwave, your satellite signals, and finally is optic fiber. One of the best technique of transmitting your signal. Okay, first wire pass. Okay, wire pass is it's an insulated copper wire. It's a wire. It's just a 2 copper wire used for short distances, and it has a very low frequency carrier. Yeah, it links the telephone neutral, the nearest exchange. A doorbell house to switch outside, we use the wire pass. Okay, this wire pass got plus and minus. The minus is it has a very high attenuation. Okay, what is meant by attenuation? I think I told you last time. Attenuation means what? Attenuation is in telecommunication. Attenuation means reduction in the signal power. High attenuation, reduction in the signal power. That means, let's say when the signal starts with a big amplitude, and by the time it runs, its amplitude drops a lot, very little. We say highly attenuated. Okay, the signal drops a lot. High attenuation. Energy is lost due to heat in the wire, the resistance wire. Okay, as radiation, since the wire acts as an aerial. Another, that's main problem. Very high attenuation. Okay, we can't use for a long distance. If you're going to use for a long distance, you need a lot of amplifier in between to strengthen the signal. So amplifier costs money. So I think wire pair is only for short distance. Another one problem of wire pair is it very easy pick up external interference that degrades the original signal. Okay, it picks up external signals. I think 1980s, when someone pick up, when there is the phone is ringing, when they pick up the call is not theirs actually. It should be the neighbors talking to someone. Okay, because the neighbor signal has been interfered, has been transmitted to your signal. Interfering happens very frequently. So the crosstalk is very obvious in early days, 1980s, because wire pair is prone to interference. easily can pick up the neighboring signal. Okay, in several wires arranged next to one another, they will pick up each other's signals. Crosstalk will happen, very common, cross-linking. So that's one other problem, crosstalk. You are receiving calls, your neighbor's calls, it's not meant for you, okay? Okay, then the next is, another problem is bandwidth. Okay, bandwidth means in telecommunication, bandwidth means is the, to be simplified, the amount of information it can carry. Okay, the amount of information it can carry. Big bandwidth means it can carry lots of information. It means you can have a big speed. Speed is high. So wire pair has a bandwidth of about 500 kilohertz. Okay, 500 kilohertz. Kilo is a very small bandwidth. Nowadays, we already have gigahertz bandwidth. This is only kilohertz. It's very small bandwidth. So it only can carry little information, like only sound. It can transmit sound, but it can't transmit video. Sound possible. Okay, consequently, a means of carrying a large amount of information is extremely limited. It can't carry lots of information like video, HD video, totally impossible by using a wire pair. Okay. So yeah, so this is advantage and disadvantage. The only advantage of a wire pair is cheap. Okay, it's cheap. The other remaining all are disadvantage. It has a very small bandwidth. It pick up noise. It has a lots of crosstalk, and yeah, very high attenuation. Okay, this is minus of wire pairs. You have to remember this frequency. In exam, they'll ask, what is the wire pairs bandwidth? Is about 500 kilohertz. Okay, so please memorize this information. Wire pair is 500 kilohertz bandwidth. Okay. Okay, now to overcome lots of problems with the wire pairs, they come out with a coaxial cable. Okay, we still use coaxial cable at the back of your TV. Now you have a coaxial cable, but now that also replaced with HDMI, HDMI cable. Okay, this is how the coaxial cable looks like. Okay, so inner wire, copper wire is the input, carries the signal input. After passes the television, the output will be channeled back into this copper mesh. Copper mesh is the output signal wire. Okay, so inner wire is the input, the copper mesh is the output signal. Okay, so essentially a pair of wire arranged so that the one wire is shielded by the other. The signal is transmitted down in the conductor. The outer conductor acts as a return wire. Okay, the outer conductor is usually connected to earth. So outer conductor is usually connected to earth. So the insulation between the copper wire and the copper mesh prevent the interference, and less interference on that. So coaxial cable, the advantage and disadvantage just opposite to the wire pair. What is advantage of wire pair? Cheap. Coaxial cable, disadvantage is expensive. Okay. All the disadvantage of wire pair is the advantage here. So more expensive, disadvantage. The advantage is less attenuated. Coaxial cable is less attenuated. So therefore, repeater amplifier can be arranged further apart. You can put the amplifier further away. Okay, because the signal not going to drop a lot. So we can do amplification later, further away. So this makes the, what do you call, the company to save cost. Amplification requires money. So another one, less prone to external interference. Okay, not much of a crosstalk if you use coaxial cable. And the bandwidth also quite huge. It's 50 megahertz. That one is 500 kilohertz. This is 50 megahertz, quite big. It's capable of carrying much more information than the wire pair, but still not good for HD videos. This is not good for HD videos yet. HD videos, I think, have to be in gigahertz. HDMI cable maybe. Okay, so that's through cable. Okay, through cable. Okay, so after wire pair, after coaxial cable, next is I skip this radio link first. I don't want to go to the air first. We go back to the optic fiber. Yes, so optic fibers. Okay, why I went to the optic fibers? Because optic fibers is competitor to the coaxial cable, because it's through wires. Okay, through wires. Okay, optic fibers is the best technology currently we have transmitting signals. Okay, optic fibers is how optic fibers looks like. Okay, it's just a fiber. It's fiber uh, which can transmit signal with due to total internal reflection. Okay, it carries a light signal. Okay, light signal, a laser light signal. Optic fibers are strands of optically pure glass, is as thin as a human hair, micrometer, carry digital information. Yeah, optic fibers carries digital information. 1010. You know the binary code. It carries that. And the digital signals is carried in terms of the light. Okay, if the light is okay, so then maybe next page I explain to that. Okay, so yeah, I skip this first. Yeah, it works based on total internal reflection. Okay, principle of total reflection. When light hit the fiber, when it exceeds critical angle, it totally will be reflected and the signal will be transmitted until the end. Okay, so you look this picture here, maybe they have a laser pointer, laser. The laser light will be connected. Laser light will transmit a signal. When it light up, it counts as 1. When the laser is shut down, it counts as 0. Okay. Let's say, for example, hello. You said hello, hello. The binary code, let's say 1000111. So the laser will blink. First, will light up, give 1, and after that, shut down. Maybe the duration is 2 microsecond. Okay. The first microsecond it blinked on. Then for 3 microseconds, the laser will shut down. So it gives you 000, because there's a detector here detects the code at one particular time interval. Okay, 1 second it light up, the detector will count as 1. When it's shut down for 3 microseconds, you're going to put 000, and when it blinks light up again for 3 microseconds, it counted as another 3 data zone 110. So digital code will be transferred, detected by the detector. Okay, yeah. So optic fiber transmits optical pulse using a principle of total internal reflection. It carries binary code. Okay. So a single optical fiber have the following parts: a thin core about 8 micrometer and has a cladding and buffer and everything. The signal is only transmitted in this 8 micrometer core. Your video HD signal transmitted through this 8 micrometer what do you call cable. It's very thin. Okay, a single optical, the core, thin glass center fiber where the light travels. Light travels only at the core. It's 8 micrometer. And the cladding and buffer coating, plastic coating are just as a protective layer. Okay. So transmitting optical paths. One single optic fiber can transmit as much as data as a bundle of coaxial wire. This is you can imagine how effective is transmitting through optic fiber compared to coaxial cable. Okay, one 8 micrometer coaxial cable signal can transmit more signals than the bundle of coaxial wires. Okay, that's why optic fibers become so famous. It carries digital information. Pulse of light or infrared is used, and the pulse are provided by the laser. And the light produces was very high frequency in order of 10 to the power of 8 megahertz. It is the blinking frequency. How fast the laser blinks. That means the laser can give out 10 to the power of 8 digital coding in a second to the detector. 10 to the power of 8. 10 to the power of 6 is 1 million. It's 100 million signals. 100 million, I think, like what? 100 million one and zeros. About 100 million, 100 million one and zeros will be reach the detector per second. Okay, per second. Yeah. So now it's still increasing the current technology. In theory, a bit of individual light wave could last about 10 for negative 14 seconds. This would allow hundreds of thousands of individual influential phone call, for example, to share the same optic fibers. Okay. So one optic fiber can carry 5 or 6 phone calls at the same time. Okay, at the same time. So 6 calls can be transmitted in the single optic fibers. Okay, without interfering. Okay, without interference. So, however, present technology does not allow control of such high frequencies. The duration of bit is governed by the fast laser providing the laser fiber switched on and off. This is at present order of gigahertz, but it's increasing as technology develops. Okay. So you see the bits last for this much, but they say current technology speed is in gigahertz stage. It's all depend to the what, how laser light to fiber can be switched on and how fast it's switched on. That determines the speed of the transmission of the digital code. Currently, the blinking of laser is like in gigahertz. Gigahertz. So pulse of light, infrared radiation travel along the fiber as a result of total internal reflection also. Sometimes they use infrared radiation. Okay, infrared radiation. Light, they use light to send 1010. Sometimes they replace the light with infrared, infrared radiation. Infrared, benefit of infrared compared to light is infrared is a short frequency. Large frequency. Then the, visible light, it should be short frequency than the light. It seems its attenuation is even lower than the light. That's why sometimes infrared is used. So if its attenuation is even lower, then again the amplifier can be placed even further. Okay, less costly. So another one, as there is no loss of energy, the total internal reflection, the light impulse can travel great distance. Yeah, this is one of the benefits. Total internal reflection means no energy loss. That means the attenuation is very little in optic fibers. So great distance you can travel without amplifying. But however, some impurities inside the optic fiber, it seems absorbs the energy. So the signal do degrade, but not as big as the coaxial cable or the wire pass. Wire pass. Okay. So in exam about optic fiber, what they're going to ask, what is the advantage of optic fibers? These are the advantage of optic fibers. You must know at least 3 in exam. In exam, they will ask, try 3 advantages of optic fibers. Because this is our current technology and so perfect, no minus has been found. First, it has a very large bandwidth in gigahertz. In gigahertz. Your coaxial cable is only megahertz, this is gigahertz, giving rise to the large transmission capacity. Okay, so you can download movies or something if you connect it with the optic fibers. So the speed going to be very high. Okay, that's a large bandwidth. And second, it's very cheap. It's very lower cost than metal wire. Copper wire is expensive. This optic fiber is very cheap. You put it at the side of the road, also nobody going to pick up because it's very cheap. And the diameter weight of the cable is less, very light. It's very light and easy to handle and store compared to copper wire. Copper wire is heavier than what do you call optic fibers, of course. So yeah, much lower cost, easy to handle, less attenuation, very little attenuation because it transmits signal total internal reflection. Fewer generator amplifier are required, reducing the cost of installation. Okay, and do not pick up electromagnetic interference. So, like sometimes you go to your what do you call your computer nearby when there is something, let's say, like what do you call, you're watching video or something. When you bring your phone call nearby, that kind of interference, they call electromagnetic interference, never happen in optic fibers because optic carries like a light signals only. And it's very high security, very high security. Not easy to steal the information from the optic fibers. And no crosstalk, negligible crosstalk, never happen. Okay, can be laid along electric railway lines and power lines, no interference. So these are the benefit of using optic fiber. The most important is there's a very large bandwidth. One, there's a very less attenuated. Two, few amplifier required. And the third one, I can say it is, yeah, never pick up EM electromagnetic radiations, interference. Okay, any misunderstanding so far? Do you don't understand anything?
No.
Okay, so please remember this at least three about optic fibers. Okay, so that's about optic fibers. So through cable, we have wire pass, coaxial cable, optic fibers. Our future, I think in the future, the best dream of every telecommunication is what? The entire Malaysia like implanted with optic fibers. Okay, so optic fibers is reliable, it's very fast, and its bandwidth is huge. Okay, but currently we are just limited areas we have optic fibers. Okay, so it's growing. Okay, so this is about all cables. Okay, transmitting your signal through cables. But if you have planted with optic fibers within Malaysia, but let's say you want to transfer your signal to other countries, like maybe to Singapore or maybe Sabah Sarawak, what do you need? You can't transmit through optic fibers because it's across the sea. So therefore, what we do, we need to send the signal through air. So your signal, let's say you type an email, and email need to be received by a person in Sabah, let's say, okay, from your laptop until reach the the station, the signal station. Let's say you have the Maxis station. You might follow the optic cable, but by the time reach the station, after the station, they will air it through air to reach to your friend in Sabah. So we need to send the signal through air. So what they use through air, we use a radio link to transmit the signal in the air. So aerials are required for radio link. We need to send the signal in a radio signal. Okay, from your house to the station here, maybe through optic fiber at underground. Okay, and come to the station. This station, they will air it by using a radio signal. So your information will be embedded on the radio wave, and the radio wave will carry the information across the sea. And later your friend Maxis in Sabah maybe, or Celcom, they have their receiving station there. Your radio signal will be received there, and from that station they will transmit it through maybe optic fiber again underground to your friend's house to receive the email or something. Okay, so the aerial are required to radio signal. Energy is radiated in the form of electromagnetic wave. It travels outwards with the speed of light. This is so what do you call speed of light, So very fast it can reach your friend. Okay, and the electromagnetic wave frequency is from 30 kilohertz to 3 gigahertz are generally referred to as radio wave. So radio wave is used. Okay, this is the rough sketch of how your signal is transmitted. This is your radio station actually. Maybe the DJ in the station is talking by using a microphone. The microphone will convert the sound signal to electrical signal. The electrical signal will be converted to maybe digital 1010 analog to digital converter. You will have in between the microphone and the codifier. And the codifier, what do you call analog to digital conversion happen 1010 codes. That code will be embedded into a radio wave in form of AM and FM modulation. Okay, this you don't know yet what is meant by AM, FM yet. But for time being, just remember that the sound signal will be embedded onto the radio signal by a term called modulation. And the radio signal will carry the information to the where you need to transmit. Then the receiving, it will have an antenna, like maybe your radio, receive that signal, and then later will send to your speaker. The signal will be converted to sound. So this is what happens. Okay, so from the radio station to your house, the sound will be aired through radio wave. Okay. So the first radio wave is used in a low frequency long wavelength Morse code. Okay, this is the early 20th century. Later, high frequency amplitude modulation and frequency modulation used to broadcast the sound and the video, operate in the same area. Okay. So AM, FM, we will talk that tomorrow. Okay. So for time being, how the radio signal is transmitted, discuss about that. Okay, guys, look at the picture on top. There are two types of aerial we have. One is aerial that transmit the signal in 360 degrees in all direction. Okay, your phone, maybe your radio antenna or your car antenna, the radio antenna is like a 360 receiver or transmitter. You have another one type. It's called transmission line transmission. Like the signal only transmitted to one direction. This happens for your satellite signals. Okay, for your satellite signals, use this. Your Astro use the satellite dish, right? So receive and give out the signals in a line of sight. So the choice of aerial broadcasting, all direction or one direction. One direction for satellite signals normally. Receiving the radio signals, choice of aerial is determined by whether the signal is to be received from one direction or all direction. Aerial with dish reflector enable the radio wave to be transmitted as parallel beam. Okay, we will come to this one. Okay, in the radio signal, there are three types of signals: surface wave, sky wave, and space wave. There are three types of wave we have. Okay, surface wave, the radio signal is transmitted on the surface of your Earth. Okay, from surface, the signal only transmitted to the surface. From one station, the signal will transmit it to another station. Another station will transmit it to another station, and too many stations are on the Earth's surface to cover the area. It's called surface wave. Okay. Let's say you like, for example, you make a phone call from Sunway to your friend in Puchong. I think the signal most probably from the Sunway tower, the signal will be transmitted to a surface wave to the Puchong station. And your friend receive it from there. Okay, surface wave. Okay, surface wave, the frequency will be below 3 megahertz. Okay. The range is only up to 1,000 kilometer. Okay, if your friend is within 1,000 kilometer, the signal can be transmitted through surface wave. Okay, so this is where the companies play around. You see, let's say Celcom, DG, and Maxis. The phone line which has a very good reception, means they have a lot of ground station. Too many ground station they have, so that the signal can be transmitted without any disruption. Okay. The one company who are like maybe not a good coverage, that means they don't have much station at the ground. Okay. So surface wave within 1,000 kilometer. The frequency is below 3 megahertz. Okay. Okay. You have another wave, sky wave. Sky wave is 3 megahertz to 30 megahertz. The signal need to be transmitted from 3 megahertz to 30 megahertz. Sky wave, the signal will channel to the atmosphere, go to the atmosphere. You see, there is a layer in the atmosphere called ionosphere, which can deflect the signal and send it to the ground again. So that called sky wave. Okay, sky waves that are reflected back by the ionosphere will reach back the Earth and will be transmitted. The signal will be transmitted to the ground again. The sky wave is a long distance. Okay, from maybe from Peninsula to Sabah Sarawak, maybe we can use what you call sky wave. Okay, sky wave. But sky wave got one problem. What is the problem of sky wave is, the ionosphere layer is depend to the weather. Its weather is too bad, raining and thundering and so on. So the ionosphere thickness is not that good. So the signal won't be reflected back. So you might lose the signal. Okay. So skywave, good advantage is long distance. Disadvantage is the reception might not be good because the ionosphere is prone to the weather. So, but human smart, what they do, they want to have a reliable, reception. They create a space wave. Space wave. This is our current technology, space wave. Space wave, we send the signal to out of space to the satellite, and the satellite will reflect the signal back to the Earth. It's called space wave. Okay, space wave, the frequency is 30 megahertz, more than 30 megahertz, because high frequency only can penetrate the atmosphere and reach the Earth, reach the satellite. So it need to be very high frequency. It's a line of sight. Dish is used so that the signal will be channeled to one direction. One direction. Wave that are transmitted in a straight line from the transmitter to receiver. It's called space wave. Using satellite, of course. Okay. So these are the three types of radio communication we have: surface wave, sky wave, space wave. Space wave, for a company to have a space wave, again, you must have lots of money to get the satellite service. They can launch one if they have lots of money, or they have to pay some money to other companies who are holding the satellite to use that satellite to transmit their signals. Okay, so space wave requires money. Okay, so you see this diagram. Sorry, not this diagram. Yeah, this diagram, the first one. You see the first one. Space wave goes up and go for a very long distance. Sky wave just move from here and hit here. Okay, and the ground wave is here. So sorry, not this diagram. I think this is the diagram. So the second diagram, you see, the surface wave covers the short region. The sky wave hit at this point, and see this region is called as the as a area where there is no signal. There will be a no signal in some areas. So a company, to have a very good coverage, they must have all type of transmission. Okay, for a long distance, they must use skywave. For a short distance, they have enough ground station to cover the areas. Okay, to have a better coverage. Okay. So satellite goes to the cell line and reach back. Some signal is sent to the ionosphere and reflected back. So this diagram tells the three types of transmitting wave complement to each other. Skip zones, there is some skip zones. So zone where you don't get what you call coverage at all. So wave not received at that region. So how to minimize the skip zone? I think the company must have another station here, maybe, to amplify the signal and to retransmit again. So more station, better coverage. Okay. Yeah, so that's about radio link. Okay. Why you need radio link? Because overseas you need radio links. You must send the signal through air. So we use the radio signals. Okay, radio wave. Okay. Another type of wave used to transmit your telecommunication signal is microwave. Okay, microwave. So microwave and radio wave are used to send signals. Okay, microwave is short wavelength or long wavelength compared to radio wave. In your EM radiation, radio is the last, so micro is above. So micro has a short wavelength. It has a short wavelength and high frequency. Okay, because radio wave has a very high frequency, it seems it has a big bandwidth. It can have a big bandwidth. Okay, so these are the frequencies used for transmitting signals. Okay, the microwave is fall under the gigahertz region, the last column. Okay, the last row is in gigahertz is your microwave. Your astro signals all are broadcast through microwave. Okay, your phone signals also by using microwave. Okay, in gigahertz frequency. Okay, yeah. So microwave is normally is a satellite signal. Satellite signal uses microwave. Okay, now you have one bad news here. The bad news is you have to memorize this frequency and the names. Okay, it's a one long list you have to memorize. Okay, and the special name. The first is the long wave, LW radio, long wave radio, MW, medium wave, SW, short wave. Okay, and finally FM, frequency modulated radio signal, FM, DB broadcast, and microwave. So in exam they will tell you, okay, SW, what is the frequency? So you have to memorize the frequency range, 3 megahertz to 30 megahertz. So by hook or crook, we have to remember these frequencies. Long wave, 30 kilohertz to 300 kilohertz. Wavelength is fine. Wavelength you can calculate by using what? V equals to F lambda. V is speed of light. So wavelength is fine. You can calculate it. Just remember the frequency. Okay. So long wavelength is 30 to 300. Then medium wave is 300 to 3. And short wave, 3 megahertz to 30 megahertz. And so on. Remember, in 1950s, maybe the earliest of 20th century, we only have long wave, medium wave, and short wave. Okay, low frequency has been used. Okay, a low frequency got one benefit, one disadvantage. Okay, if you want to transmit a signal at a low frequency, low frequency means what happened to the wavelength. When frequency is low means wavelength is how much? Big or small? Wavelength get big. Okay, you see wavelength, a long wave, 30 to 300 kilohertz. The wavelength is 10 kilometer to 1 kilometer. You know the wavelength. So if wavelength is big means what advantage is the signal can really diffract when it comes to a hilly places. In hilly places, it can really spread. The signal can really spread. So better coverage. Okay. So short frequency means one benefit is it really can spread. It really can diffract. Okay, that's the benefit of sending signal at a low frequency. Military normally use low frequency transmission because they want really spread. Okay, but one problem of sending low frequency signal is the wavelength is big. Therefore, the size of aerial is determined by the wavelength of the signal. I think it's about quarter wavelength, if I'm not mistaken. So let's say the wavelength is 10 meter means the aerial size must be at least 2.5 meter aerial needed to receive the signal. So inconvenient lah. You can see in military movies, when they want to communicate with the station, what they do, they grab a kind of a radio transmitter, they pull out the aerial going to be very long. Okay, going to be very long because of what? The signal they're receiving as a big wavelength. Okay, so a big wavelength. One convenient is really can diffract, can spread. Middle of jungle also they can get the signal. It really can spread. But problem is the aerial size must be big. Okay. But another one problem of sending a frequency at a low frequency is it's found to be the bandwidth is small. Bandwidth is small for low frequencies. If bandwidth is small means what is the problem? It means they only can send sound. They can't send videos or any HD videos, quality videos you can't send. You only can send sound. So that's one problem for low frequencies. So FM radios, TV broadcasts used a very high frequencies. When used high frequencies, the bandwidth seems big, have a big bandwidth, so they can carry more information. Okay, the name also quite weird. You have to memorize the name. Long frequency, medium frequency, high frequency. After that, maybe this happens at 1970s, 1980s, maybe very high frequency was discovered. So they give a name very high frequency. Then when the technology improved, they go for more than 300 megahertz to gigahertz region satellite. TV broadcast was possible. So they name it as after very high frequency, they name it as a ultra high frequency. They don't have name. They put ultra high frequency, UHF. Okay. Then technology improved from 3 gigahertz to 30 gigahertz. They name it as a super high frequency. And finally, I think they don't have name. They don't have idea of naming anymore. They put extra high frequency as the last one. EHF. I think your microwave, your astro signal, I think in form of UHF or SHF. Your microwave signal. Your astro signal. Sorry, HT. Okay. So you have to remember the names. You have to remember the corresponding frequency. Okay. So your phone maybe use SHF, super high frequency, by using microwave. So one convenience is you see the wavelength is 10 centimeter to 1 centimeter. Therefore, your aerial inside your phone must be quarter of this length. If the signal is 1 centimeter wavelength, the size of aerial you required is a quarter of it. 0.25 centimeter of length of aerial is required. So it's very, very convenient. Last time in 1980s, end phones, the aerial will be visible outside the phone. But now you can't see the aerial anymore, all built in, because the signal you are getting has a very, very huge frequency. Therefore, the wavelength is too short. So you have a short aerial required. Okay, class. So the microwave are radio waves, SHF waveband 3 gigahertz to 30 gigahertz. With high frequency, short wavelengths, only a few centimeter. Wavelength or radio wave determines the length of the aerial. Mobile phones, aerial must be, for the sake of convenience, short. Microwave are suitable. The bandwidth also increases. So HD video, everything can be sent to your phone because the bandwidth is huge. But only problem sending the signal in a super high frequency is it should be a satellite signal. So the company must have satellite service. They must have one satellite, or they pay other companies to make use of their satellite to send the signals. Okay. So another few slides only. So you see the microwave, if I want to talk to your friend in maybe UK, okay, your signal will be transmitted from Malaysia to the satellite, and the satellite will send the signal to the UK through microwave transmission, and your friend will receive it. Okay. So the bandwidth of the microwave link is order of gigahertz. Large bandwidth means as large capacity of transmitting information. Microwave always point-to-point communication, one side, okay, not 360, where signal are transmitted directly from transmitter to receiver. Okay, the range of transmission is limited to the line of sight. Relay stations are used. Relay station, like from the ground also you can send the microwave. A relay station is a type of station where capture the signal, amplify the signal, and retransmit again. Because microwave you can't send it for a long distance without amplifying. You have to amplify the signal in between. Okay, so we need a relay station to amplify. Okay, very long distance microwave are transmitted beyond the atmosphere and sent back to the earth by communication, satellite communication. Okay. So this is your dish, your satellite dish. It's a transmitter and receiver, both dish dimension looks the same. So transmitting signal, the signal will transmit it from the center point. It's going to hit the dish. The dish going to reflect the signal, going to form a parallel signals. This parallel signals is a line of sight signal. Line of sight, it goes straight to the receiver. And your TV, maybe outside TV, outside your house, you got the Astro dish. The Astro dish receives the signal from the satellite from the outer space, line of sight, reaching your dish. It's a parallel, what do you call? Parallel signal. The parallel signal will be reflected to your receiver. Then you get the signal into your house. Transmitting element placed at the focus of parabolic reflector. Focus wave power onto the receiving element. Wave power is radiated in a parallel beam. Aerial is found at the focus of the reflecting dish. Yes. So this is radio signal. Microwave. So your astro signal in the rainy days, when it's raining, you don't get signals. Why? Anyone? Why raining days you didn't get signals? Because when it's raining, the water molecules are blocking the, what do you call, the signal. When the signal comes in and pass through the water molecule, what happened? It will be refracted. Water molecule will refract the signal. So the signal will be refracted. When refracted, it won't anymore will be a parallel beam anymore. So when the signal come and hit at the side, it won't reach the receiver. It might reach outside. So therefore, your signal, your reception not that good when there is raining. Why? So you say the signal has been refracted and diffracted. Diffracted also happened. Two water molecules, when the signal pass through between the gap, it will be diffracted. So diffraction and refraction causes the signal become bad in the rainy days. Okay. So this is so when you send an email, this email will be sent through to the nearest relay, maybe through optic fibers. And reach the relay, your signal will be transmit through microwave and until reach your station or to your friends. Okay. The intensity of the wave as the distance from the transmitter increases, the strengthen amplifier at regular distance. Yeah. So one big problem we face is when the distance of transmission greater, the wave need to be amplified in between. Because of what? Because the strength will be decreasing due to attenuation. Okay, the signal will be attenuated, so we need to amplify the signal. Okay, guys, that's all for today. Okay, so what you learned about today? You learned about this 5 mode of transmission. You need to know good and bad about these 5 modes. Wire pair, all bad except it's cheap. Coaxial cable, all good, only bad is expensive. But coaxial cable is a loser compared to optic fibers. Optic fibers, all good, nothing is bad. It's a big bandwidth, cheap, and never pick up electromagnetic noise, and so on. So optic fiber is the mostly they will ask an exam. Radio wave and microwave used for in the air. When want to cross the sea, you need to pass through the air. So radio wave and microwave is used. Microwave is line of sight. It used for satellite signals. Microwave, high frequency broadband is good for the shorter aerial and convenient to us. But transmitting signal in big frequency, we got one big problem. What is the problem? It can't spread. It can't really spread. If the signal sent in high frequency go into a hilly places, frequency is very high, wavelength going to be very short. It can't really diffract. So houses close to hilly places won't get the reception. So that's the problem of sending signal in high frequency. Short frequency mainly used by military, because the signal is not clear is fine, but they want the coverage. So they go for a low frequency, high wavelength, so that the signal really can spread. But what the disadvantage they're going to face, the quality of the signal going to be very bad. Second, the aerial size is going to be huge. Okay, guys. So this is a fact to remember on zero calculation. Okay, just read through, try to understand it. Okay. Any questions? Okay, so I see you tomorrow. Okay, I see you tomorrow with the next slide, FM and AM. We're going to discuss about FM and AM.
All right. Thank you, sir.
Okay.